Express negative 5, negative j4 in polar form. First thing first, what are you going to do? This is where you are going to. You are given that z is equals to negative 5, negative j4, right? Which is case 1, the rectangular form of your complex number. Then case 2 says that the polar form z is equals to what? R all into bracket cos theta plus j sine theta. That is, you need r and you need theta. By the time you know r and theta, you do substitution. True or false? True. But now, this is how it works. I will have used, to get r here, use this formula. To get theta, use this formula. Right? Identify your b and a. In this case, your a is what? -5, and your b is what? -4. But if you go with this approach, you will get the same thing. By the time you go with this approach, using this formula to solve for r, using this formula to solve for theta, you will get your answer, then you substitute. But what do we say? We said case 1 must be equivalent to what? Case 2. Let's solve for r here. R is what? R is equals to what? Negative 4 square plus negative 5 square. Which is what? Square root of 16 plus 25. Meaning square root of 41, right? Which is equals to what? 6.41. The next unknown is what? Theta. How do we get theta? Using this formula. So from here it becomes theta is equals to tan inverse of, what's your b? -4 over -5. Meaning tan inverse of 4 over 5. So run your calculator. Theta is what? Tan inverse of 0.8. What do you have? 38.66 degree. 66 degree. Now you solve for r, this is your answer. You solve for theta, this is the answer. What it means is that, come back to equation 2, do substitution, right? Meaning the polar form of this question, which is z, becomes what? 6.4 cos 38.66 degree, okay, plus j sine 38.66 degree. This is the polar form, right? This is the polar form. What about the Cartesian form? Z is equals to what? -5, -j4. This is the Cartesian form. This is the polar form. This is the Cartesian form. Now we said that your polar form must be equivalent to what? Cartesian form. How do you confirm? Are you getting me? How do you confirm? By that you input this in your calculator. 6.4 plus 38.66 degree. You must get -5. 6.4 sine 38.66 degree. You must get -4. If you are not getting it, it means, try that first. Let's see. If you are going to get -5 or -4. From here, by that you press 6.4 plus 38.66, what do you have? 4.99. Approximately what? 5. Okay. You are having positive 5. 6.4 sine 38.66 degree. What do you have? Approximately what? 4. Positive J4. Now check what you got now with polar form and the initial question. Is it the same? Why? Because of the sign. Initially we have negative, but now what we got by polar form, we got positive. Do you know what it means? No. Why we are having this is because the what we use here, the way we found our theta here, this is not the way we're supposed to do it. In your quadrant, you have first quadrant, second quadrant, third quadrant, and you have fourth quadrant. Are you getting what I'm saying? You have first quadrant, second quadrant, third quadrant, and what? Fourth quadrant. Now what it means is that given a question under complex form, if you are given a rectangular form of complex number, you want to convert it to a polar form, meaning you have to bring that complex that rectangular form Plot it on your x and y axis so as to know the quadrant it belongs to, be it the first quadrant, second quadrant, third quadrant, or fourth quadrant. Now let's see. Meaning this is wrong. All what we are doing, it is wrong. That's the meaning. The correct way to answer this question, first thing first, bring out your quadrant. And by your quadrant, the x-axis is your what? Real part. The y-axis is your what? Imaginary part. Now let's represent -5, -j4 on this quadrant. This is first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Why we are doing this is that we want to know if this Cartesian form of this complex number will it be at the first quadrant, will it be at the second quadrant, third quadrant, or fourth quadrant. We don't know yet. Let's plot. Let's see. Now let's plot -5. Will it be in the positive or negative region? Negative, meaning I have it here. I have 5 here. -j4. Will it be at the positive or negative? Meaning I have it here. This is 4. So what this means is that this given complex number is at the what? Third quadrant. You understand? It's at the third quadrant. Now, drawing your diagram, you then have something like this. This is 5 and this is 4. Agreed. This is 5 and this is 4. Any question on that? This 5, -5. This is the real part of z. This is the imaginary part of z. -5, this is it. -4, this is it. Now, using same idea, you have your angle here. Let's call the angle here alpha. I get what I'm saying? Let's call the angle here alpha. Now, from here, call this place r. And we already know how to get our r. The value of your r, let's solve for our r. Our r is still what? Square root of, using this formula, b square plus a square, which is what here? 4 square plus 5 square. Your answer will still be the same thing. Square root of 41, which is equals to 6.4. Right? Now, from here, tan alpha is equals to b over a. Right? Meaning alpha is equals to tan inverse of b over a. That is, alpha is equals to tan inverse. What's your b here? 4 over 5. Your answer is what? Answer for alpha is what? 38.66 degrees. This is alpha, but you are interested in what? Theta. What do you have here? Theta, and not alpha. Meaning the first angle you get is alpha. Though not necessarily, in this case, you might decide to use E. Are you with me? This angle, you might decide to use E. You might symbolize it with anything. But what it means is that your first angle that you get is not the actual theta. It's not the what? Actual theta. From here, from this place, you need theta, right? But expected, you will get an angle. But that angle is not the actual theta. So this angle, this first angle that I'm getting, I'm denoting it as alpha. If you are the one solving, you might denote it as E. You are still doing the same thing. But here, I'm denoting it as alpha, meaning alpha is equals to 38.66 degrees. Now the question is, how do I get this theta itself, which I'm interested in? Now, take note. In your quadrant, this is the first, this is the second, this is the third, this is the what? Fourth. First, second, third, fourth. Is that correct? All students take calculator, right? Now, for this first one, I'm going to get I'll get an angle. This is my first angle. So I'm saying that angle should be alpha. Are you getting me? Let's say, after I'm presenting this complex number in Argand diagram, let's say it falls on this first quadrant. The first angle that I'm going to get, I'm representing it as alpha. Are you getting me? Let's say it falls on this second quadrant. I'm still representing the first angle to be alpha. Let's say it falls on this third angle, this third quadrant. I'm representing it to be what? Alpha. Let's say it falls on this fourth quadrant. I'm representing it to be what? alpha, but I'm interested in getting what? Theta itself. Now come back here. To get theta from this first quadrant, theta is equals to the alpha you get. For this second one, theta is equals to 180 minus alpha. This third quadrant, theta is equals to 180 plus alpha. For this fourth quadrant, theta is equals to 360 minus alpha. The first angle I got is 38.66. Now let's get the actual theta, the actual angle that I want to substitute into equation 2. Meaning theta is equals to, following this principle, theta is equals to what? 180 plus 38.66. And what you say your answer is? Theta is equals to what? 218.66 degree. So in this case, you already know your R to be 6.4. Theta to be what? 218.66. Do substitution. Given that Z is equals to -5 -J4. This is the rectangular form. This is the rectangular. Now for complex form, Z will be what? What's your R? 6.4 all into bracket cos 218.66 degree plus J sine 218.66 degree. And this is the answer. By the time you press this in your calculator, you end up getting this. And earlier we said your rectangular form is equivalent to your what? Polar form. Now take note, this angle is in degree. You can convert from degree to minute. Degree minute. Meaning from here, how do you convert this angle? If you have 218.66, it's still the same thing as 218 plus 0.66. Yes or no? Yes. Now from here, how do you convert from degree to minute? So these are it works. 218 all into bracket 218 degree all into bracket 0.66 times 60. Now press your calculator. What do you have? This time this is what? 39.6. Let's say approximately 40. You get approximately 40, meaning 218 degree 40 minutes. So in place of 218.66 degree, you can just put 218 degree 40 minutes. Then here too, you can sine 218 degree 40 minutes. So do you know why this is important? Let's say you are solving, and even you guys are doing theory now, it's better, but now you are doing OBJ. What if the first answer, by the time you solve, you didn't see that answer there, and you are seeing this? You'll be confused. How did they get this? This is what they did. They converted from degree to degree minute. And how do you go about it? From 218.66, is this the same as saying 218 plus 0.66, right? Now this 0.66 multiplied by 60. Yeah, that's 1 minute. So multiply by 60, meaning 218 is still in degree. 218 degree 40 minutes. So you substitute, you get an answer. So if it is the first, what's your question?
Will the answer be
Yeah. That's how you leave it. You leave it. But there's a short form for this also. What's that? Yeah, you've converted. I'm saying that. Let's say you are doing OBJ now, and you've gotten your answer. You already know it is correct. But what if the answer you got, you didn't see it in the option? What does it mean? Let's say the answer has been converted to minutes. How did they convert it? This is how they converted it. Meaning from 218.66 degree, they converted it by saying 218 plus 0.66. This 218 is still in degree. All into bracket 0.66 times 60. And your answer, you got 40, meaning 40 minutes. So in place of the initial degree, substitute what you got, and this is it. You understand? But now, this is the full form of polar form. The short form, this same answer, you can still write it as Z is equals to 6.4, then this sign, right? 218 degree 40 minutes. In place of this whole answer, this is the short form of your polar form. It's either you see this or you see this. You understand? So that's how it works. So can you see that by the time you input this in your calculator, you got the initial question given to you, meaning you've converted from rectangular form of complex number to polar form of complex number. And this is very important because there's this course you do here to apply the electricity. AC, you'll be using complex number to solve electricity. Meaning if you don't know complex number very well, you won't understand that one in depth, and the 3 unit course.